Welcome to the Professor's DuBois channel. This is Professor Victoria, and this video is a mini lecture based on a lecture covering material from Chapter 3. Disclaimer, this is in no way equivalent to our actual lecture, where we discuss and practice the material in much more detail. We begin this lecture with the basic format for chemical reactions. Chemical reactions are written left to right with an arrow. The compounds or elements to the left of the arrow are reactants, and to the right are products. Reactants produce products. There is a law of conservation of matter that is applied to chemical reactions, and basically this means that any element present in the reactants must be present in the products in the same quantity. Realize that it may be a different compound in a different state. For instance, many reactions involve burning carbon-containing fuel, which produces carbon dioxide. The carbon in the carbon fuel may be as a solid as a reactant, but as the gas carbon dioxide as the product. To comply with the law of conservation of matter, we have to balance our chemical reactions. To do this, we add coefficients only. These are full-size numbers that go in front of the compound. We do not use subscripts to balance equations because this would change the ratio of atoms in the compound or element. The coefficient only changes the number of those elements or compounds in the reaction. To balance this equation, we can put the coefficient number 2 in front of AB. Then we have 2 atoms of A on both sides and 2 atoms of B on both sides. We call this a balanced chemical equation. This problem is more difficult. To balance this reaction, we add the coefficient 3 in front of A2 and a 2 in front of B3 and a 6 in front of AB. A balanced equation shows us the mole-mole ratios between species within a chemical reaction. We will use these as conversion factors in calculations to convert moles of one species, like B3, into moles of another, like AB. This is a word problem that requires that you can go from a chemical name to chemical formula. Notice how hydrogen in a chemical reaction is how hydrogen exists in nature, as a diatomic element, H2. To solve this, we must first write the chemical reaction, then balance it. Balancing takes practice and patience. Do not expect these to be easy initially, but if you put in the practice time, you will become proficient. These are some additional practice problems for you to work on. As I stated earlier, we have the mole-mole ratios between species in balanced equations. We can use the molar relationships to convert from moles of one material to moles of another material if we have the balanced equation. To solve this problem, we must first write the chemical equation and then balance it. Remember the diatomic elements? Since the problem uses pure oxygen and hydrogen, it is necessary to write these as they exist, H2 and O2. After we balance the equation, we can use the coefficients as factors. To solve the problem, start with the 0.6 moles of hydrogen over 1 and use the factor 2 moles of H2 to 1 mole of O2, and then solve for the moles of oxygen. We can use the mole island visual roadmap for reaction stoichiometry. In this case, we can convert between moles of 2 different compounds or elements on mole island using the coefficients from the balanced equation. If you do not find the mole island visual helpful, you don't have to use it, but being able to explain how to use the mole island to appear would be a good exercise for both compound and reaction stoichiometry problems. Thanks for watching. Please give this video a thumbs up and subscribe if you would like to see more mini lectures on the Professor's DuBois channel.